looked at an introduction in our last set of notes. We have some steps to help us get through solving these quadratic inequalities. And the first thing is to make sure that the graph relates back to 0. So what that means is that we want to have our letters on the left, and it kind of goes with alliteration. Letters on the left, if it points to the left, then it's less than. And if these symbols give you trouble, maybe at the top of your paper you might want to write down that these two symbols are the less, and then these two have to do with the greater than. And I'll try to point that out as we go along, because if we know those symbols, I think that can help us a little bit as we solve these quadratic inequalities. But we want to make sure that it relates back to 0, which means that our quadratic is on one side of the inequality and 0 is on the other. We can see on letter A that it does relate back to 0. And then we're going to factor to find the roots. Once we find the roots, we're going to sketch the graph, and we can use our calculator to help us. Sometimes the sketch is going to fit on our graph. Sometimes it's not. Sometimes it's just going to be a sketch. To solve the inequality, we need to decide whether we're going to be looking above or below the x-axis. And that's why it's important to know those symbols. Which one's less, which one's greater than. Then we need to determine, are our roots going to be included? Is there an equal in the problem? And if there is, then they're included, and if it just says less than or greater than, that means that they're not. And then finally, we'll record the solution with set notation, with a number line, and with interval notation. So let's start our first one here, where we can still see our steps. And the first step, remember, says to factor. So let's take x squared plus 2x, and I'm going to relate it back to 0 by saying equals 0. I still do want to point out that over here in the problem, this really does say greater. So we need to be aware of that. But to factor it, we don't need an inequality symbol. And when we factor, our GCF is an x. And when we factor that out, we had 2x's, we took out 1, we still have 1. 2x divided by x is 2, we had 1x, we took it out. And hopefully for you, you can say, oh, x equals 0 and x equals -2. And if you can't, then what we do is we take x plus 2 and we set it equal to 0. So then we end up with x equals -2. So already, before we even type this into our calculator, we know two values on our graph. We know here, and we know here. But let's use our calculator to help us get a little bit better picture. Really, the most important here is that we do have a sketch, but if you go to y equals, and we type in x squared plus 2x, and graph, we'll see our picture. And in fact, we can look at the table and get a couple values for this, like 1, 3, and is there another one there? -3, 3. So -3, 3. Or -2, 0. 1, -1. 0, 0. 1, 3. So here's our picture. So what we're looking at here is, this problem says x squared plus 2x is greater than. When we're solving this, because it says greater than, we want to look above the x-axis. And by the way, if you're unsure, this is the x-axis. And where that is, and here I kind of like to use the highlighter, this might be too dark, but that means that we're going to be here, and we're going to be here. That's the part of the graph that's going to be above. And what you see there is that we had to use 2 highlights to fill in where it was above 0. And when we have 2 highlights, what our notation is going to look like is it's going to look like x is less than -2 from our root to the left on our picture. All of those x values are going to be less, or x is greater than 0. All of these roots are to the right of that. So once we come up with those values here, by the way, it is just less than, there's x is less than -2, there's no equals, and x is greater than 0, no equals. Which means when we come down here to fill in our number line, we're going to put an open circle on the -2. There's no equals, so it's an open circle, and the values that are less than are going in this direction. It's also x is greater than 0. Again, still no equals with that, so we're going to go this direction. And then we can finish this problem here with our interval notation, which is a little bit wacky. But it's going to be -infinity to -2. Infinity always has a parentheses in it. Because there is not an equals, x is less than -2, this also has a parentheses. So we're coming from the far left, from -infinity, that's smaller than -2. When we get to -2, we're going to stop. There's going to be a gap. So what we do is we say U, or union, which means that we're joining with our other part, which starts at 0 and continues on to infinity. Again, infinity always has a parentheses, and because there's no equals, 0 will have a parentheses. So there's the first one, and at least we have seen a little bit, have been introduced to this earlier. But let's try another one, and it's the same picture here. So the good news is we already know that our roots are x equals 0 and x equals -2. And in fact, we can draw in the same picture on here. So it's -3, 3, -2, 0, -1, -1, 0, 0, 1, 3. But in this particular problem, now, it says x squared plus 2x is less than 0. We're relating back to 0. We actually have the problem factored. We've got the graph. And now we're on step 3, which says to solve the inequality, we need to decide, are we going to look above or below our x-axis? And this time it says less. So what we can do is we want to go below the x-axis, which is in this part of the graph right there. And notice that we only put in one highlight in that particular one. So to answer this question then, when we get down to the symbolic set notation, all of our answers are going to be in between -2 to 0. No equals. There was not an equals in the problem. It says x squared plus 2x is less than 0. Same roots that we got on part A. When we fill this in, we're still going to have open circle on -2 and 0 because there's no equals. And it's going to be everything in between. And in terms of interval notation, this is going to look like an ordered pair. Because there's no equals, it's going to be -2, 0. But when there's not an equals, we have parentheses in there. But that just means that we're looking at everything in between -2 to 0. So we determine whether the roots are included, they are not, and then we recorded the solution using our symbols and our number line. So first examples may be a little bit confusing. We'll keep doing some more examples. And once again, when we take a look at these, and you can fit this in between because your C and your D, they're the same problems. I know that it says x squared plus 2x minus 24 is less than or equal to. But what I want to just write here is less, because that's what we're looking at. Are we looking at less than or are we looking at greater than? I know there's an equals in the problem. Because our first step, does it relate back to 0? Yes. So we're going to factor. So let's take the x squared plus the 2x minus the 24, and I'm going to set it equal to 0. But ultimately what we're going to have to do is we're going to split the middle. And the factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Will any of those combine? Either add or subtract to be 2? And they will. It's going to be the 4 and the 6. In fact, it's going to be -4 and +6. And we end up with x squared minus 4x plus 6x times 24. Grouping. And when we do, our greatest common factor in the first group is x. And we're left with x minus 4. Our greatest common factor in the second group is 6. And we're still left with x minus 4. And what we see is we have an x minus 4 in each group. And then we have our x plus 6. And I hope that at this point you can say x equals 4, x equals -6. If you can't, here's the work. X minus 4 equals 0. We add 4 to both sides. And we get x equals 4. And x plus 6 equals 0. We subtract 6 from both sides. And we get x equals -6. And we can put those values on our picture over here right away, because it says sketch the graph. If we can make it more accurate, we will, but at the very least we want to put our roots, our zeros, our x-intercepts on here. So we're going to fill in the 4 and the -6. So we've at least got that. So if we take out our calculator though, don't erase what you have in there already, because the x squared plus 2x is still part of this problem. All that we need to do now is we put the minus 24 in. And when we take a look at that picture, what we see is that we're not going to fit everything on there. If you want to get technical and go back up here to the table, you can see that we could graph that point 3, -9, and 5, -9, if you so -5, -9 chose. But the bottom line is that our picture is going to look something like that. And if you don't have a graphing calculator, at least you should know that it's an upright quadratic. And then what we need to decide is, are we looking above the x-axis or below the x-axis to help us solve this problem? Well, it says less, so we're looking below. And when I fill this in here with my highlighter, up to you whether you want to use a highlighter or not. Here's our part. And we only drew in one highlight on here. So when we fill in our set notation, we're only gonna have one inequality. Now in this particular problem, there is an equals in our problem, so we're gonna have equals there. And make sure that you put this in alphabetical order, numerical order. -6 is smaller than +4. And we can draw our picture here. We know everything is in between. There's an equal, so it's going to be a filled-in circle on the -6. It's going to be a filled-in circle on the 4, and everything in between. And then an interval notation. Because there's an equals in this problem, we're going to have -6, 4, but the equals has a bracket when we're dealing with interval notation. Nice part about D is we already know what the picture looks like. We can fill in our values here at the -6 and the +4. It doesn't have to be super accurate. We do want to put our roots as accurate as possible. We've already done the factoring for this. The difference on this problem compared to letter C is that this time we're looking at greater. So in contrast to letter C, greater than 0 is going to be above here, which means we're going to be looking at this part of the graph. In this part of the graph. And we put 2 highlights into our problem. So when we fill this in here, it's going to be x is less than -6. And I need to look and see, does it have equals? No. Or x is greater than 4. Because we have the 2. Every single time you have 2 highlights, 2 parts, then we're going to have to split it up like I just did with the or. In terms of the number line, no equals in there, so we're going to have an open circle. We're going towards the left, and we're going towards the right, but there's not a filled-in circle because there's no equals on there. And then in terms of interval notation, it's that kind of wacky way. Negative infinity is our smallest value to -6. Infinity or negative infinity always has a parenthesis. Since there's no equals here, that's going to have a parenthesis. Joined with union. And over here, it's going to be 4 to infinity. Again, both have parentheses. Infinity always has a parenthesis. So we flip it over. Now I'll flip our notes over. When we look at letter E, you may just want to watch this for a moment, but we do relate back to 0, which is what we want. But in terms of the factoring here, I just want to point this out. In order to factor this, we have -x² plus 4x minus 6, and I'm going to relate it back to equals 0. It's very difficult to factor when the x² term is negative. So what we would do to factor here is we would take out a -1. When we factor out a -1, that's going to change all of the signs in here. You get x² minus 4x plus 6 is 0. X² became positive, the 4x became negative, the 6 became positive again. So we're going to look at the factors of 6, which are 1 and 6 and 2 and 3. Well, either one of those factors combine, either add or subtract to be 4? No. We cannot factor this. And this is when it's probably more helpful to have the graphing calculator. So we're going to take out our calculator. We're going to go back to y equals, clear that out, and type in our function. -x² plus 4x minus 6. And look at our picture here. We at least can get some values. We can type this in. Looking at some points here. So we have 0, -6, and -1, the +1, -3, 2, -2, so here's our picture. Let's go back and look at what we are looking for. It says -x² plus 4x minus 6 is less than 0. So are we looking above or below our x-axis here? We're looking below. And the thing is that our entire graph is below the x-axis. So now when we want to answer this, the set notation looks something like this. X, and it kind of looks like an E. It's kind of like a C with another line there in the middle. And it means X is a member of, and then this symbol here is all real numbers. A capital R with the second line in it. X is a member of all real numbers. And again, since everything is below the x-axis, then our entire number line is going to be filled in. From here, from here. And then how do we write that in interval notation? Well, we're kind of familiar with that. It's negative infinity to positive infinity. Infinity always has a parenthesis. So when we look at letter F, we already know what the picture is going to look like, so we can fill that in. Got our 0, -6, our 1, -3, our 2, -2, our 3, -3, our 4, -6. Same picture. But as we look back at our problem here, this time our symbol says greater than 0. Well, where is our graph greater than 0? And it never is. It's always below. So in terms of our symbolic notation here, we're going to go X is a member of the empty set. You may have seen that symbol that sometimes is said as no solution. But since we have no solution, there's nothing that we're going to fill in on the number line. And then in terms of interval notation, I usually just still stick with the no solution symbol. I want to jump to letter H here, and I don't want to rush through it. If I have time, I may go back and do G, but I want to talk about letter H for a couple of minutes, because this is the first one that doesn't relate back to 0, for starters. Whew. So when we take a look at this one, here the 3x² minus 5x is greater than 8. We need to relate it back to 0 for starters. So the first thing we're going to do is we're going to subtract 8 for both sides. We get 3x² minus 5x minus 8 is greater than 0. And now we have it related back. And maybe if you struggle with these symbols, you just want to write greater right by that, just as a reminder. We're looking for greater. Where I'm going to spend my time here for a couple minutes is factoring. Remember, when we factor, we're going to have to take the 3 times the 8, which is 24. And luckily, at least we've seen 24 today. And it's 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And when we look at this here, do we have any factors that combine to be 5? In fact, if we want to get technical here, it's going to be 3 minus 8. But we're splitting the middle. This is 3x squared plus 3x minus 8x minus 8. And we're grouping. So we have a group here and a group there. We're going to factor out the greatest common factor from each group. And we get 3x. And then we're left with x plus 1. We had 2 x's, we took out 1. 3x divided by 3x is 1. Be careful with this minus sign in between. It really does need to be written, and sometimes people skip that for whatever reason, I don't know. But over here, when we factor out that 8, which is our greatest common factor, it's negative 8x divided by negative 8, which is x. Negative 8 divided by negative 8, which is 1. And now what we have is we have an x plus 1. That's in common in both groups. And then we have our 3x minus 8. And we're still trying to find the roots. That's what happens when we're factoring. We take the x plus 1, set it equal to 0, and I hope you can tell me that x equals negative 1. You might have to do a little bit of work on this one. But we subtract 1 from both sides to get x equals negative 1. And over here we're going to get a fraction. Adding 8 to both sides, we get 3x equals 8. Divide both sides by 3. So we get x equals 8/3, which, by the way, is the same thing as 2 2/3, which is approximately 2.67. Just so you know all the equivalent values, and it is approximately because 2/3 is a repeating decimal. But once we know that, we can go back on our grid, even before we type it in the calculator, and we know where it's going to cross. Negative 1, and then 2 2/3. In fact, when I type it in the calculator, I'm only going to write down a sketch of it because I don't think that it fits on our graph so much. But what you have to type in is 3x squared minus 5x minus 8. So remember, it has to relate back to 0. So we type that in. We can look at our picture. And we mostly get the picture on here, but if you look at the table over here, we've got some random values. It's not going to fit exactly on there. So let's just sketch it. We've got our roots, and that's the most important part. We see a picture, so we can get a good approximation of our picture. And remember, it's only a sketch, so I know it's not completely accurate there. But we wrote down earlier, we said that 3x squared minus 5x minus 8 is greater than 0. So when we look at this from the highlighted perspective, we need to go above the x-axis. And we had 2 highlights. So when we fill in our symbolic notation, therefore, we're going to have x is less than 1, negative 1, or x is greater than 8/3. The values that we found when we factored, we can fill in our number line. There's no equals in this problem, so we're going to have open circles. So negative 1, x is less than. Those are values that are going towards the left. And then x is greater than 8/3. So we're going to go between 2 and 3, 2.67 approximately. And then we're going to go towards the right. And finally, for our interval notation, we're going to say negative infinity to negative 1. Again, no equals in this particular case, so they're all going to be parentheses. Joined with, that's the union, the U symbol, and it's going to be 8/3 to infinity with parentheses.